Hi everyone, welcome to our webinar, An Introduction to Vehicle to Grid. Before we get started, I'm just going to do a bit of a sound check. So if you can hear us okay, please select the hand symbol on your control panel just to show us that you can. And if you're hearing any feedback or anything, please let us know through this control panel in the questions section. I'll just give you all a minute just to respond. Okay, seems like everyone can hear us all right. So thanks for joining us today. Before we get started, just a little bit of housekeeping. So our webinar is set up so that you can hear us, but we can't hear you. On your control panel, you can submit any questions or comments in the questions section, and we're going to cover all the questions at the end. So I'm Heather Quinn, Assistant Programme Manager for Scottish Transport at Energy Saving Trust. I'm joined today by my colleagues Ross Kirkland, Senior Programme Manager of Technical Projects in the Transport team, and Christiana Nicoletti, who's providing technical support today. So I've had a bit of technical difficulties with my laptop, so Christiana is presenting for me. So I will be prompting her to change the next slide when it's time. This webinar is brought to you by Home Energy Scotland, a Scotland-wide free advice service funded by the Scottish Government and managed by the Energy Saving Trust. Home Energy Scotland offer free and impartial advice on energy saving, so keeping warm at home, renewable energy, greener travel, cutting waste, etc. And that's to help people in Scotland create warmer homes, reduce their bills, and help tackle climate change. And this webinar is funded by Transport Scotland, an agency of the Scottish Government. So next slide, please, Christiana. Okay. So first off, I just want to thank everyone joining us today. We hope everyone's safe and well during the coronavirus outbreak. It's a really uncertain and difficult time, so we just want to help the government, the NHS, and everyone by quickly reiterating the government guidance. So you can find this guidance on the government's website, or you can visit the NHS website for any advice on symptoms and self-isolating. So just stay at home, keep in touch with friends and family remotely, by phone, email, or video chat. Only have face-to-face contact with people that you live with, and only travel for essential journeys, so that's to get food, for doctor's appointments, getting medication, for your daily exercise, and if necessary, for work. So stay local and try and travel actively by bike or walking when you do go out. Thank you. So we'll move on to the next slide. I'm just going to go through the agenda for today. So I'll give a brief introduction on transport emissions and electric vehicles to just set the scene for those of you who may not have an electric vehicle yet. Then I'll be handing over to Ross, who'll give an introductory overview of vehicle to grid technology. And after that, we'll briefly cover our top tips for charging at home now without V2G. And then we'll go into a Q&A session as well. Okay, so next slide. So the latest Scottish transport statistics, which are published every year, showed us that 37% of Scotland's greenhouse gas emissions came from transport. So 40% of which came from passenger cars. And as you can see, compared to other sectors, not much has really changed. So after over the past 27 years, Scotland's transport emissions have only dropped by 3.7%, and that's significantly less than energy supply, waste, and even agriculture. and this does not even take into account international flights and shipping. Plus, between 2016 and 2017, transport emissions rose by 2%. A couple of trends that could be responsible for this is that Scotland now has the highest number of car registrations ever. So there's more cars on the road than there ever has been before. People are opting for bigger cars as well, such as SUVs, which produce more carbon dioxide than smaller medium vehicles. And the government has declared a climate emergency, and they've set some strong targets and policies to address this, one of which is phasing out the need for petrol and diesel vehicles by 2032. Next slide, please. Okay, so this is where electric vehicles come in. So, and what part that they play in tackling transport emissions. So to highlight the benefits of electric vehicles, I've carried out two vehicle comparisons to demonstrate these. So I selected a small petrol vehicle and a large diesel vehicle and compared to a similar size EV model for each. So firstly, pure electric vehicles benefit from zero tailpipe emissions. In fact, battery electric vehicles or pure electric vehicles have no tailpipe. So there's no CO2 released during journeys, which contributes to climate change, and no nitrous oxides released either, which contributes to poor air quality and public health issues. And even when taking into account the energy required to charge the vehicles, there's still a significant carbon saving. So every year, in the case of the small petrol car, you could save 1.6 tonnes a year, or over 2 tonnes a year for the large diesel car as well. And that's, to put that into perspective, that's around 20% of your annual CO2 emissions as a household. So that's a really significant reduction in your household emissions. Then, as you can see, there are also fuel cost savings made from switching to electric vehicles because they are currently cheaper to run. And in 2017, the biggest source of electricity in Scotland came from renewables, and this is only growing, meaning our electricity and our fuel for electric vehicles is only getting greener. And if you can click, Christiana. So the big question for today is, if everyone switches to electric vehicles, how can we manage this new demand for electricity? And that's where the vehicle to grid technology comes in. So if we go to the next slide, I'd like to hand over to Ross Kirkland, who's going to introduce you to the technology. Over to you, Ross.
Good afternoon, everybody. Hopefully you can hear me clearly. So as Heather said, my name is Ross Kirkland and I work in the technical projects team in Energy Saving Trust Transport Division. My team work with local authorities throughout Scotland, mostly analysing how electric vehicles and charging infrastructure are currently used, and we try to anticipate how changing technology and greater proportions of electric vehicles on Scotland's roads might impact the quantity and type of charging infrastructure that's going to be needed in the near future. So this presentation is designed to be an independent introduction to vehicle-to-grid technology. I hope you'll find it useful and learn something new, but if not, then there is a wealth of information out there, mostly online, and you can find out more details about specific vehicle-to-grid products or any one of the over 50 trials that have taken place across the world. I've included a link at the end of this presentation that digs a little deeper into the sort of global history of vehicle-to-grid technology. But like every emerging technology, sort of advancements can be quite fast-paced. So I would recommend you keep that in mind when you're reading older content, as it might not always sort of reflect the current picture. And I'm just going to change slide. So I'll start just with a little bit of policy context. So the Scottish Government's 2045 net zero carbon ambitions give us 25 years to transform the way that the Scottish energy economy operates. Some people are going to think that that's plenty of time, and others will think it represents a real challenge. I personally believe that it's perfectly possible, and if nothing else, these strange times that we are currently in prove that whether voluntarily or otherwise, we do live in a world where technology and positive behaviour change can very quickly transform the impact that our personal and collective actions have on the environment. So net zero carbon won't be met by a single technology or concept. Net zero economy needs a network of different technologies, and each of these need to interact and complement one another. So as Heather said, it's people walking, cycling, wheeling, it's electrified heat, solar photovoltaics, plug-in vehicles, smart charging, and probably much more. It's a little bit of everything. So vehicle to grid technology is just one of those options and can help improve our management of our transport energy consumption. And this and similar technologies can help unlock multiple benefits and opportunities for domestic and business consumers, for the electrical grid, and also for wider society as well. So what are we going to cover today? So we're going to discuss what exactly is vehicle to grid, who could benefit. We're going to touch on how much people might be able to benefit from, and what kind of equipment is included in vehicle to grid systems, and what might you need to participate now or in the future. And we might even pose some questions of our own, although we might not be able to get the answers. So first, we need to talk about energy bills, and please do stay with me. I promise that this part is important and relevant. So domestic customers are normally billed in kilowatt hours, which is a measure of power consumed over time. And bills are relatively simple, where you just multiply out the cost of kilowatt hours, add the daily standing charges, and VAT at 5%. 5%. For those with Economy 7, Economy 10, or other specialist tariffs, such as common with for those with electric storage heating, the precise amount of energy that they're charged for the electricity will usually vary depending on when they used equipment. If it was off-peak, for example, at 11 p.m, it would cost less than if it were at 5 p.m. So a bit of an open question. How much cheaper would, for example, using a shower or charging an electric vehicle have to be before you actively changed when you decided to take it? So on the face of this, that seems reasonably fair. You get charged based on how much energy you use and sometimes when you use it. But is it fair? How closely does that match what the energy supplier actually pays at wholesale cost? So wholesale energy markets actually operate on a half-hourly settlement basis, and that's to say that electricity is traded in half-hourly periods, so 24 hours split into 48 subsections. So for many domestic consumers' bills, the supplier estimates when the energy was used, and that's usually against average demand profiles. So wouldn't it be easier if we were charged based on specifically when we used electricity? And that could open up opportunities for us to be a little bit more flexible with our energy use, allowing us to choose to save money and reduce the environmental impact of our actions and our lifestyles. We ought to be sort of careful what we wish for, because many businesses are billed on a half-hourly basis, and their bills can be far more complex, with 10 plus individual billable items, and also VAT at 20% rather than 5%. So what is half-hourly metering? Well, unlike domestic consumers who are billed in kilowatt hours, some commercial consumers of electricity, well, their bills use units of measurements like kilovolt amps reactive. And this means it's not just about how much power is consumed, when and for how long. It's also about how efficiently the electricity was used. The less efficient the system, the higher the energy costs, as you might expect. So those different half-hourly periods for these customers are split into 3 categories based on the perceived or estimated impact on the grid transmission and distribution costs, and these are known as use of system costs. So the three half-hourly categories are shown in this chart here, and this is an example of electricity demand on a weekday. So you've got the off-peak period shown in green, the mid-peak shown in amber, and then finally the peak period of the day shown in red. They are shaded in red. So the weekend half-hourly periods are a little bit different because there's actually no peak period on a Saturday or a Sunday for billing purposes at least. So these use of system periods are based on the industry's historical experience. They're used to set up the pricing structure and generate bills for half-hourly customers. But actual real-world peaks in demand will vary depending on things like weather and even perhaps what TV show is on and at what time. So extra time at football, for example, can make predicting spikes in electrical demand quite challenging, as well as threatening the peace of probably quite a few households as well. So smart meters, some of you might be familiar with, or some of you might be less familiar, but they record electricity effectively in real time, and they accurately record when energy was used, and they send this to energy suppliers as often as has been agreed with the customer. So it might be half-hourly, daily, or monthly. So to summarise, we can see that using current smart metering technology and existing half-hourly billing processes, it's possible to make bills more accurate, and it's also possible for certain consumers to lower electricity bills, and that's by taking advantage of electricity being cheaper for them at certain times of the day. There's a whole service industry set up around maximising the efficiency of energy used and billed on a half-hourly basis for these industrial consumers. But are these opportunities open to individual households and businesses? Well, since 2017, energy suppliers have been allowed to settle domestic customers on a half-hourly basis, and that paves the way for smart energy tariffs that can reward you for your flexibility. But why am I telling you this? Well, first of all, thank you for sticking with me through that explanation of half-hourly billing. At the start of the presentation, I said that vehicle to grid was just one example of technology that could help us better manage our energy consumption, reduce our impact on the environment, and potentially save money. And energy billing is really the important part here because it's the interface between every single grid-connected renewable source of electricity and every intelligently controlled electrical load, whether that's electric vehicles, a domestic battery system, a heater, a dishwasher even, or any other appliance. And if we understand the billing, then we're in a better position to exploit those opportunities that energy flexibility provides. So smart energy concepts are about maximising renewable generation, supplying it to you at the lowest possible cost, and allowing you to generate income from your assets. And vehicle to grid technology is a clever bit of kit that's designed to reward you for your electric vehicle's built-in flexibility. So what is vehicle to grid? Well, simply put, vehicle to grid is two-way, or sometimes known as bi-directional charging. So your car becomes physically and digitally connected to your home, office, or other point of connection to the local or national grid, for that matter. And this enhanced connectivity allows you to buy electricity from the grid when it's cheap and sell it back to the grid when it's more expensive. So effectively, it turns your home, your office, or your other place into a virtual power plant. There could be many different motivators for using vehicle to grid, and these could include matching your electrical demand to renewable electricity generation, and that could be on or off site. It could be providing additional generation to support the electrical grid during periods of high demand and low renewables availability, or even providing various services to the electrical grid operators. Sometimes these services are known as demand-side response. So you can see from this chart here an example use case of vehicle to grid. And what it shows is an individual consumer buying electricity to charge their car in the middle of the night. To the left-hand side of the chart there, shaded blue, you can see the buying the electricity there. So the vehicle charges from 50% to 80% in this example, and that's it reaches that 80% capacity well before the car is ever needed in the morning. It's then driven to a place of work, say around 10 to 15 miles away, and uses 10% capacity for that journey. It sits at a steady state of charge of 70% until it's time to go home, and it then uses another 10% to get back home. As soon as it's home, the vehicle gets plugged in and it just discharges another 10%, so around 4 kilowatt hours, into the grid, and that's helping reduce the peak demand from the home or neighbouring homes. The car then automatically stops discharging to the grid at 50%, and that could be because that's the minimum threshold that you've set, or it could be because that was all that was needed, but from the grid that day. And the process would just automatically start all over again during the night, charging to 80% to be ready for the next day's journey. So how does it work? Well, there are several different companies that offer vehicle to grid for domestic or commercial scenarios, and there's too many to mention every single one. As I said, there's over 50 trials that have taken place across the globe, and each of these will have their own unique products, services, or vehicle to grid package. But generally speaking, most vehicle to grid systems will include a mobile app or a web platform, and you would use this to set your preferences, things like what's your minimum and maximum battery state requirements, and things like when would you need the car to be ready for its next journey. So you might set these once and forget about them, or you might change these settings regularly depending on what your individual needs were. So you would plug the compatible vehicle, and it does need to be a compatible vehicle, into a special vehicle to grid charger. And largely you can then just forget about it and it'll charge and discharge as needed without any further input. Or alternatively, if you're into your tech and you want to keep an eye on things, then you should be able to log in via that mobile app or web platform access, and you'll be able to see what your vehicle's doing, whether it's charging, whether it's discharging, by how much power, what power rating is it discharging, and you should be able to get an overview of how much money you're saving as well. So the vehicle to grid service provider should do the rest. Their platform will have algorithms built in and forecast closely match your electricity supply to market conditions. And the idea is that that would save you money against your electricity and transportation costs. So what features does a vehicle to grid charger have? Well, first of all, just now, most of the vehicle to grid charging systems use the CHAdeMO connector, which is shown there on the slide. That's the round connector with the 4 pins there. And the reason for that is that Japan really sort of led the way in developing the early vehicle to grid hardware solutions. There are other alternatives that have been trialed, but CHAdeMO seems to be the market leader just now. Most will have either Wi-Fi connectivity or perhaps a 4G dongle, so a SIM card effectively to allow communication. They'll have some kind of intelligent web platform. They'll have electrical switching relays so that they can ramp up and down and turn on and off the electrical controls. Most of them will just operate off a normal single phase electricity supply, the kind that you would get in a domestic property. And most of them will charge and discharge at or around 6 kilowatts. Some of the commercial vehicle to grid systems will go up to about 10 kilowatts, but it's largely accepted that low power charging is best for the grid and all, for the marketplace, and also for the battery health, etc. Many of the systems will use or interact with a SMETS2 smart meter, so that's the second version of the smart meter, but most will also have their own onboard metering so that they can communicate how much energy has been used and discharged, so imported and exported for reconciliation of billing. So a bit of a bonus fact, your smart meter's in-home energy monitor, or IHD, that refreshes roughly every 10 seconds using low power radio waves. But the smart meter system can take around 30 seconds or up to 30 seconds for a full two-way communication to be completed. So by having that built-in Wi-Fi or 4G or maybe even 5G in the future, that means that the energy suppliers might be able to benefit from faster response times. So when a signal is sent for to start importing into the vehicle, the vehicle can respond to that quickly, and the opposite when, for whatever reason, the electricity from your batteries needed for other purposes, then that signal can quickly be sent and the system can respond. So the vehicle-to-grid systems mostly use CHAdeMO connector and protocol, which I've already mentioned. And the vehicles that are compatible are some of the Nissan Leaf models and the Nissan ENV 200 van as well. As mentioned in the previous slide, the vehicle-to-grid system will usually have a method for you to enter your preferences and interact with the charger. And usually you'll be able to access this on a live basis to see what's happening. So how much could you benefit? So this is the tricky part really, and I can't give you a specific answer about how much you will or could save, since there are too many variables, and although there are a lot of projects that have demonstrated how the systems will work, there haven't been many systems which have went to the market. So things that will affect how much you could save are things like where you are, so geographically, will distribution network operators or grid operators buy your flexibility? Will it be worth more where the grid is most vulnerable, or will it be the same and standardised across the UK? How flexible you can be will be important. Will you be comfortable making 20% to 80% or 50% to 90% of your battery availability for vehicle to grid purposes? And how long will you actually be physically connected to that vehicle to grid charger? So the larger the flexibility window, the larger the value that would be attributed to that flexibility. Other factors will include how efficient can your home be during these peak times. Current consensus is that you should sort of only discharge the vehicle's battery to the grid at quite low power rates, certainly under 10 kilowatts. So the less power that you personally use in your own building, the more that's available for exporting to the wider grid for other customers to use. Other factors could include the future energy mix. So how closely does renewable generation match demand? Offshore wind has recently become the cheapest form of generating electricity in the UK. So it's going to become about, the peaks and troughs in renewable generation and how does this compare to demand? And that will likely influence the value of all flexibility services, including vehicle to grid. So I did have two good examples of live projects to give you, but on checking these yesterday, it turns out that one of them, the OVO Energy vehicle to grid trial, has now closed to new entrants. But despite this, I think it's still useful to just quickly run through what was on offer, so you can get a flavour for the kind of introductory deals that might become more common in the near future. So OVO were offering 30 pence per kilowatt hour as an export tariff. So that's when you export to the grid from your vehicle's battery. Slightly less, 26 pence per kilowatt hour, if you had solar on your roof or on your property. They were also offering a 75 pound credit on the bill, and a free vehicle to grid charger and smart meter if you needed one. Another example comes from Octopus Energy under their Power Loop vehicle to grid trial. For most of you listening today, it wouldn't be possible to take part in that trial because it is only for homes in the UK power networks distribution area. So that's sort of the southeast of England. But like the OVO offer, I thought it would be good to quickly review what they offered, or are offering, should I say. So Octopus Electric Vehicles offers a vehicle and wall box vehicle to grid package, and that costs £299 per month. And the package also includes a new 40 kilowatt hour Nissan Leaf and a vehicle to grid charger. It uses Octopus Energy's Agile tariff, which is a sort of smart flexible tariff, and that varies the cost for every half-hour period, and can even in some instances pay you to use electricity at times of oversupply. And that also offered £30 off your electricity bill. For business consumers, things are looking a little bit rosier at present. The opportunities are a little bit better. If you're a business consumer and you have a half-hourly metered electricity supply, as I've described, and a vehicle to grid compatible EV, like the Nissan Leaf or the EMV 200 van, then you can take advantage of EDF's vehicle to grid package, and that includes a fully installed vehicle to grid charger, a commercial one, ongoing support and maintenance, asset management and a reporting portal. Well, they claim that the vehicle to grid revenues are equivalent of up to 8,000 free driving miles per year. So all trials do have specific terms and conditions. So I would encourage you, if you are thinking about any of these vehicle to grid opportunities that are going to be coming out over the next few years, if you make sure you read through all of the terms to decide whether it's the right thing for you. And as promised, there's a link on the slide there to a bit of further reading on the 50 plus vehicle to grid projects across the world today. And that's it from me. Over to Heather.
Perfect, that's great. Thanks, Ross. Really, really insightful. So if everyone can start getting their questions in for Ross, we'll probably start the Q&A about just 5 minutes time. I just want to apologise for my slides. I know that some of you could only see part of it. It was really zoomed in. What I'll do is I'll send everyone the PDF version of these slides so you can see the breakdown of Scotland's emissions, and you can see the vehicle comparison report that I had done as well. So just get slide number 7 up for you. Oh, appears to be sort of zoomed in again. Sorry, bear with us. That's it, perfect. So maybe the EV you currently have or you're planning to get isn't V2G capable, or maybe you don't quite think V2G is not for you just yet. But not to worry, you can still charge your car smartly. That is sort of saving money and reducing carbon emissions when you're charging from home. So our top tips are, regularly switch your suppliers. So if you are charging from home, your electricity cost will go up, and that's a fact. So it's really important more than ever to see if there's a more suitable tariff for you and to regularly keep up to date with how the market looks. So Ross did touch on the fact that there are a number of EV tariffs available for marketed towards EV drivers, that encourage charging overnight or charging in half-hourly intervals if you have a smart meter. And that goes on to sort of our second tip as well, which is, get a smart meter. So it will depend on the availability of the meters from your energy supplier, but we would encourage you that when you get offered one that you do take them. They give you a greater insight into your energy use in your home, more accurate billing, which can hopefully lead to lower bills as well. And thirdly, charging your car overnight. So as you saw from the graphs that Ross was showing, peak demand does tend to be sort of first thing in the morning and at night when everyone's sort of coming home from work and popping the kettle on, making their dinner and everything. So do try to avoid charging your car as soon as you get home from work and instead opt for overnight while you're asleep and when the demand from electricity is low. And that's also when electricity tends to be its greenest as well. So some EVs and chargers have apps that you can have on your phone that allow you to set a time for when your car starts charging. And if not, you can always sort of set yourself a wee reminder and pop outside and plug your car in just before you go to bed. But as we touched on as well, some tariffs on the market are designed to help you charge your car overnight anyway. And finally, so look into renewables for the home. So whether that's installing solar PV panels on your own roof to generate some of your own electricity, or if that's not an option for you, look into energy suppliers that offer 100% renewable tariffs if that's affordable for you and suitable for you. And next slide. And again, as sort of Ross reiterated too, is that it's not about one solution, it's not all about technology, it's also about changing our behaviours. And we are in a climate emergency. And electric vehicles cannot be the only solution. So we all need to try and eliminate unnecessary car journeys, regardless of fuel type. We recommend everyone follow our sustainable travel hierarchy. So share your car journeys with others. This could be colleagues or sharing the school drop-off duty with your neighbours, and anything to reduce the number of cars that are on our roads. Make the most of public transport if it is available on your route. It's a much better use of your time. You can catch up on emails, you can read a book, or pop on some music or a podcast and enjoy your own company in the peace and quiet of your own headphones. And even better, travel actively. So when we say travel actively or active travel, we mean cycling and walking. It's the most sustainable form of transport. We would recommend replacing short journeys with active travel wherever possible. Plus, as well as environmental and cost savings, the health benefits are huge. So these stats to the right of the screen there come from a report published by the NHS and Public Health England in 2013. And they see walking as a vital form of exercise and travel for people in the UK, mainly because it's free to do, requires no equipment beyond a pair of shoes, and 96% of the population can do this unassisted. So not only does walking improve our overall fitness and reduce our risk of certain diseases and cancers, it improves our life expectancy. It's great for our mental health and overall well-being as well. It's much better for us to be outside in the fresh air than stuck inside a car sitting down. And if we could go on to the next slide. Okay, so before we go into questions, just a note to say that Home Energy Scotland offer free advice on sustainable transport. So we can compare your current vehicle to an electric alternative or help you replace those short journeys with walking or cycling. Also, over the past 8 years, Energy Saving Trusts have provided financial support to help with the initial upfront cost of an electric vehicle. But as we are coming to the end of financial year, our interest-free EV loan has now closed. We're funded annually, so please do keep checking our website for more information on the funding that will be available in April. So Home Energy Scotland also give you advice on reducing your fuel bills, finding a new supplier and installing energy measures or home renewables. So do give us a call if you want more information on advice. Um, and also let us know on social media if you decide to go ahead with any V2G trials. Drop us a message on Facebook or drop us a message on Twitter. What I'll do is I'll share our social media handles with you in the slides that I send out to you. Also, we have an app for existing EV owners called EV Life. This is part of a data capture project funded by Transport Scotland. We want to know things like your mileage, your charging behaviours beyond what we see from the public charging networks. We want to know how you're charging from home, and a little bit around your motivations as well. So this information will be sent to Transport Scotland, and it's really valuable in setting sort of future policies and future support for EV drivers as well. So I'll send some information about that too. But what we'll do is we'll go into the Q&A section. So if you've not already posted a question, get typing away and submit some so we can ask Ross. So Ross, if you're ready, got the first question through. Can you hear me, Ross?
I can hear you, yes.
Perfect. So do you anticipate other models and EVs with CCS connectors becoming V2G compatible soon?
Well, that's a good point, and as I said, CHAdeMO has been the market leader in this, mainly because Japan really got behind it after the problems that they experienced post the Fukushima accident. I don't know specific timetables about when CCS would, if at all, integrate that technology, but I do know that given the prevalence of CCS, it certainly would make sense for that to be integrated. However, it is always dependent on whether there's a need for it. So whether the DNOs are set up to purchase that flexibility, whether the energy suppliers find that they can get enhanced value out of trading energy in that way at scale. And largely, I would suspect that if the answer to both of those is yes, then CCS would become VTG compatible in the future. I do believe that they are looking into it, but I don't have specifics on when, if at all, that would be available.
Okay, fab, thanks. And what are the benefits of V2G for preserving battery life? Could unnecessarily discharging the battery every night reduce the lifespan of it?
Yeah, another good question. So I am not a battery expert, but I have read a little bit about it. There is some conflicting or competing ideas and evidences. But what I would say is that other factors could have just as big an impact on battery life, such as driver behavior, how frequently is heavy acceleration being used, to what extent is regenerative braking being used, and also how frequently are faster rapid chargers or ultra chargers being used. I would certainly say that the OEMs to date have largely stood behind the battery warranties for the purposes of these trials, and the consensus that I've read recently seems to be that as long as charging is charging and discharging is at lower rates, then it will either have minimal impact, or as you've sort of pointed out, some people even claim that it could have a positive impact on maintaining and extending battery health.
Fab. And is there much energy lost with using V2G?
Yeah, that's another good one. So clearly got some experts on today, which is great. There has been some talk about the efficiency losses associated with charging electric vehicles at rates which are less than their maximum design. I'm not yet again not an expert in the actual charger technology itself, but I believe it's got something to do with resistance losses. Hopefully that answers your question.
Fab. And the next one is, will older EVs be able to take advantage of V2G once it's established, or will it just be new models?
So I think some legacy models, if you want to call them that, are backwards compatible. As I said, Japan had sort of been the leader in that. I wouldn't be able to tell you specifically what year that starts with, but I would say that if you've got an older Nissan Leaf or ENV 200 van and you're interested in exploring this technology more, that you get in touch with whoever you intend to have those services delivered by, and they'll be able to confirm whether the vehicle's compatible or not, and whether there'll be any impact on your existing battery warranties and all of the facts that all of the other supporting features that go with that.
So one about Powerwall. So, are you able to cover some of the pros and cons for the homeowner of static storage, e.g. Powerwall, compared to V2G? I think these technologies are often thought to provide the same function when they're operated in a different way. What are your thoughts on that, Ross?
So a couple of things that, quite a complex issue, but a couple of things that sort of jump out at me. I believe that power walls have a faster response time, or can have a faster response time. So there might be that there are additional functions that power walls are better suited to. But what I have read is that ideally, where somebody is in a fortunate position to be able to afford all of these admittedly quite expensive technologies, a little bit of everything, as I said, is probably the key. So integration with solar energy, intelligent loads, other intelligent loads such as heat pumps or intelligent appliances, combined with behaviour change about when you choose to use energy that isn't needing to be used at a specific time, it all adds up together to a sort of to maximise the efficiency of your energy profile, and that's most likely to give you the largest benefits.
Fab. Um, and just on integration of other technologies as well, are there other trials that explore are you aware of any trials that explore the integration of PV with EV charging that utilizes V2G specifically?
Yeah, I would struggle to give you the precise name of it, but if you go to the link that I provided at the end of the slides, there's a historical example of a study which I think was in the Netherlands, which had a strong focus on solar PV. And I'm sure that there are very many that there are others throughout Europe and beyond that are continue to look at how solar PV can be integrated with that.
Perfect. And the trials that the trial examples that you mentioned in your presentation, are they available and running in Scotland?
So the Octopus Energy one is only the UK Power Networks distribution area. I believe the OVO Energy project was open to people in Scotland. However, as I said, it has now closed to new entrants. So I would probably advise everybody to keep their eye out for updates on whether there's extensions to those projects. I believe there's EDF are doing a lot of work in this area as well, so there may well be developments in that front.
Fab. So we've got a couple of questions about the same thing. So does the grid always have to be a national grid? Could it just be a building? Or is there scope to have vehicle to house, i.e. using the car battery to supply power to cover house electricity demands?
Yeah, yet again within the 50+ projects there's been across the world, there's been examples where vehicle to grid has been integrated into BEM systems, so building energy management systems. So that's about actively managing how a building's energy profile interacts with vehicles that are parked within its grounds. You can pretty much look at this from any angle you want, really.
Perfect. And are you aware of any planned government support for future V2G projects?
I'm not aware of the specifics of what opportunities are available, or whether the current situation will have any impact on those plans. But yet again, these are all publicly advertised. So if anybody's interested, then I would recommend keeping an eye out for what organisations like BAYS and Innovate UK are doing in this sector. Everything has to be publicly advertised, so that information should be available to everybody and updated as changes are made.
Great. And unless we get some last minute questions, it looks like this is the final question. Is the export to the grid limited in the same way that solar is? So not being able to export more than 4 kilowatts?
So there will be, under the current regulations, there will be specific limits put. But what I would say is that as technology moves forward beyond trials, and as these market mechanisms emerge, those regulations don't necessarily need to become static. But I would have thought that there would be a maximum that anybody would want to export because of the reasons that we've already discussed about battery degradation, and also the limitations of cable size, etc. So somewhere between the 0 and 10 kilowatts is probably the sort of power band that we're looking at for vehicle to grid in a domestic setting.
Perfect. Well, that's all the questions that we've got through. Thanks everyone for sending those in, and thanks very much, Ross, for taking the time to present that. It was really informative. I've definitely learned something new as well. So thanks for listening, everyone. Stay safe and best wishes. If you have any other questions, you can email us at sustainabletransport@est.org.uk. I'll be emailing you all PDFs of the slides, and within the email, I will highlight all of the links for further information and further reading that myself and Ross have highlighted. So thanks, everyone.